Assalamu alaikum. My name is Himayasin and today I would be talking in this video about the details of my project of the course Digital Logic Design. Random number generator. The main idea of the project was to generate a circuitry in which random numbers are generated and to display its binary and decimal representation respectively. The application of this circuitry can be helpful in games such as Ludo or activities such as gambling. The logic that I applied is that I used the timer IC to control the timing of the generation of the clock pulse and the speed of the clock pulse that is generated. Counters are also used to generate numbers, and segment display and logic probes are used to display its decimal and binary representation respectively. The major components that I used are 555 timer IC, resistors, capacitors, JK flip-flops, in which two pins J and K are shorted to make a T flip-flop, 7-segment display, logic probes, and or NOT gate basic gates which are used to alter the inputs given according to the truth table and the expression that are formed for the counters. Now let's see the circuit diagram in the next slide. So this is the circuit and the logic diagram in which at the left side you can see a timer which includes a 555 timer IC, and the output, that is the pin number 3, is connected to a switch. When the switch is turned on, that is the switch is on, the clock pulse is transmitted to the clock pin of the T flip-flop, and when the switch is off, the transmission is stopped. Two capacitors and two resistors are also connected. Then moving on to the counters, I have made two counters. One is from 0 to one which counts from 0 to 6, and one which has a random sequence and counts from 0 to 5. 7-segment BCD display is used to display the decimal representation. Basic gates are used to alter the input given to obtain our desired results, and logic probes are used to display its binary representation. These counters are specifically designed for this project according to the sequence we require. So there were different modules in this project. Timer, which then when the clock pulse is generated, it is passed on to the counters, which then generate numbers according to the sequence they possess, and then display happens, that is the representation of its binary and decimal parts. So let's look in detail about the timer IC. To develop a custom timer according to our need, we used resistors, capacitors with the 555 timer IC. Pin 3 is the output which gives the clock pulse, which is then connected to a switch. With pin 5 and 6, resistors and capacitors are attached. The capacitors are of value 10 microfarad and 1 nanofarad respectively, with resistors 10 kilo ohms each. This generate these values of resistors and capacitors, the clock pulse is generated very rapidly, which gives the impression that the numbers are generated very randomly at a very high speed. Counter and display. For the counters, I have used T flip-flops and or NOT gates, logic probes to represent its binary representation, and 7-segment display to represent a decimal representation. For counters, I made two counters. One counter counted from 1 to 6 and the other with a random sequence of 0 to 5. The truth table of these are given in the project report, which is attached in the zip file uploaded on Google Classroom. These counters were made using T flip-flops, which were obtained by shortening J and K pins of these flip-flops, where Q is the output. Now, let's see the running simulation of the product. This is the product where we can see a timer, then a counter, one counter which counts from 0 to 5, and another counter with the random sequence with numbers 0, 1, 2, 3 and 0, 1, 2, 3, 4 and 5, with logic props at the end and basic gates which are used to give the inputs according to the expression we have obtained from the truth table. A 7-segment BCD display, and these are the components which are used. On running it, as this is off, so let us turn this switch on. When the switch is turned on, the clock pulse is transmitted and the numbers are being generated at a random pulse. So when the switch is turned off again, the transmission of the clock pulse has now stopped and number 45 is displayed. 4 from this counter and 5 from this counter. This is 3-bit plus 3-bit give us 6-bit. So for the binary of the 4 is displayed, that is 100 respectively, and for the 5 binary 101 is displayed respectively at the end of each of these counters. So this is the whole project which generates random numbers. So this is the video in which I have briefly explained my project, the modules and the components that I have used. Thank you.